Okay, so welcome guys back to Thorough Academy. Today we are going to learn about general organic chemistry. A very important topic of organic chemistry, which is required to know how the reactants are get converted into products via intermediate formation, and how the intermediate formation occurs via different effects, and how these effects help them. So what we will learn here. Here the introduction to GOC. This GOC, I have already told you what here GOC, that here we are going to learn mainly about the different types of effects, different types of reactive intermediates which are going to form, how are they going to be stable, and what and how the different reaction conditions will lead to different products. So there are now different types of electronic displacements. Here these effects, like some of the effects which we are going for, which we will go through in the next few slides. Like one of them is inductive effect, resonance effect, mesomeric effect, hyperconjugations or the Bacon-Newton effect. These are some types of electronic displacements, and these electronic displacements are these are mainly different types of electronic displacements. One is a sigma electronic displacement, and another one is a pi electronic displacement. The first one we will talk about in today's lecture is the inductive effect. So what is the inductive effect, and then we will going to learn about the stability order of species through examples, and how the inductive effect will going to help us in knowing the stability of different species. Okay, so general organic chemistry is the backbone of the branch of organic chemistry. As I have told that without general organic chemistry is the basic criteria to know reaction mechanisms, to know different intermediates, and to know stability of different species, and to do a comparative study between different species, how they are reactive with respect to each other. Okay, so and the general GOC or general organic chemistry mainly comprises of three parts, as the types of electronic displacement effect, as inductive effect, mesomeric effect, and so on. There's types of species, means reactive intermediate, and reactive intermediate, basic, acidic species, and there's stability via electronic displacement effects. We will understand this. And types of reaction mechanisms by which path reaction will flow. The reaction will occur under a set of conditions. Then for another set of conditions, this substrate will follow another reaction path to reach the product. Okay. So another thing which I need to mention here is two important things before we go into inductive effect, that is substrate and reactant. So what is substrate? Substrate is that chemical which will undergo bond rearrangement or bond breaking, so that it can form the product. Now to induce such bond rearrangement or bond breaking, we require some chemicals. These chemicals are known as reagents. Also, these reagents will require some specific chemical conditions, specific chemical conditions, or specific set of physical conditions like temperature, pressure, etc. Types. Now we will learn about. Now we are directly going to learn about types of electron displacement effect. First of all, the inductive effect, which we are going to learn in today's chapter, today's lecture. So this is one inductive effect. The inductive effect is mainly occurs in sigma bonded atoms, which are sigma bonded atoms, sigma bonded molecules. Sorry. the sigma bonded molecules where there is a high electronegative difference, or simply an electronegative difference between two atoms. Oh, so this is the basic requirement for it. Second one is electromagnetic effect. This is also one very important effect, but a temporary effect. This unlike inductive effect, inductive effect is a permanent effect. It will always be there. Electromagnetic effect is a temporary effect. It is the movement of pi electron cloud here involves. Hyperconjugation effect or Nathan-Baker effect. Here we will it is a here the mainly the bond here mainly we will see that the pre-existing bond will break to give stability to the molecule, and when the pre-existing bond breaks, generally a hydrogen bond with carbon CH bond breaks, where the electron which gets where the bonded electron gets incorporated in the pi electron incorporated into pi electron form, and gets stabilizes the molecule by delocalization. Another is resonance effect or mesomeric effect. Resonance effect is also the movement of pi electron cloud throughout the molecule. Means in pi electron cloud throughout which induces the stability to the molecule. Delocalization or displacement of electron is a very vital criteria for the stability of molecule. The electrons cannot remain static at one place. In the inductive effect, in inductive effect, first of all, inductive effect occurs in molecules where there is presence of sigma bond. Pi bonds are not involved in inductive effect. In sigma bond, moreover, not only sigma bond, molecules having difference in electronegativity, such as methyl chloride CaCCl. There is a electronegative difference between C and Cl. Now, electronegativity is the tendency of an atom or an element to pull the bonded pair of electrons towards itself. So, to pull the bonded electrons towards itself, and pull the bonded the inductive in inductive effect, where it occurs. First of all, it occurs in molecules where there is presence of sigma bond, and where there is a presence of electronegative difference. There are no pi bonds are not involved in inductive effect. So first of all, in sigma bond, and so the basic criteria for inductive effect to occur is the compound should have sigma bonds, and there must be electronegative difference between two atoms. So like for example, methyl chloride CH3Cl, there is a electronegativity difference between carbon and chloride. Now what is electronegativity? We are learning about electronegative difference. So first of all, we should learn what is electronegativity. Electronegativity is the tendency of an element or an atom to pull the bonded pair of electrons towards itself. So which leads to formation of a partial charges over the two different atoms where there is an electronegative difference. The atom which is pulling the bonded pair of electrons towards itself has a del minus charge over itself, and the atom from where the bonded pair of electrons moves away, that atom gets a delta positive charge over it. So this is the main criteria of inductive effect. So there is you can see the partial displacement of sigma bond electrons towards more electron. As I have told, there is a displacement of sigma bonded pair of electrons as a partial displacement, but not the partial displacement means so there are molecules like in ionic compounds, the charges are completely separated. There is no presence of bond. There is only electrostatic force of attraction in case of ionic compound. But in case of these covalent bonded molecules or polar covalent molecules where there is electronegative difference, so, such molecules are called polar covalent compounds. So in such molecules bond exists, but there is a partial charge separation as due to electronegative differences. So you can see that, and obviously a sigma bond is required. Partial charges are developed. As I said, del minus charge is developed over the element which is more electronegative, and del positive charge which is more electropositive, or from which the bonded pair of electrons are removed. So the partial more or simply we can say a dipole formation occurs in the molecule. The elements or the atoms which withdraw elements or atoms or the group of atoms which withdraw the sigma electrons from carbon or any element, from any element, then it is known as electron withdrawing group. The electron withdrawing group, it is called minus I group, but the reason for the withdrawing is electronegativity. That we should remember. It is without electronegativity, this inductive effect would not have occurred. Another thing, now suppose as if now the element which is withdrawing the bonded pair of electrons towards itself, they are called electron withdrawing group, or we can simply write them as minus I group in short. Now we can think from the other way around, that the group which are becoming del positive charge or electropositive, they are like pushing or donating the bonded pair of electrons towards the more electronegative atom or group. So we can say that this electropositive group or electropositive atom, they are electron donating group, or in short we can say them as a plus I group. This effect, obviously this effect decreases. This electronegativity differs because first of all, when you take a very large molecule, suppose butyl chloride. In butyl chloride, first of all, when the electronegative difference is more pronounced between the first carbon and chlorine rather than second carbon and chlorine. This attraction effect decreases with distance. So and it is generally up to 3 atoms. Now we have to know about orders, how the different there's a priority order of minus I groups. So this is the priority order of minus I groups, which is the highest. So first of all, it is trifluoride ammonium ion, then trimethyl ammonium ion, then NH3 plus ion, NH3 plus ion, then NO2, then cyanide, then aldehyde group, then keto group, then acid, then carboxylic acid group, then fluorine, chlorine, bromine, iodine, then ether group or alkoxy group, then alcohol group, then alkyne group, then amine group, and phenyl group are nearly same. They may interchange at some point depending on other effects also, but their minus I effect is nearly same. Then we can say the ethylene group and then hydrogen. See, you must remember this by heart. There are many questions in JEE mains and NEET exam coming over the year, where you have to specify the order of stability of molecules, or order of acidity order of basicity, in which this type of this order you have to remember. So you must learn this order by heart. You may take this screenshot of this. Okay, so I hope you have taken the screenshot. So we are going to the next slide. Now there are some questions for you. These are the similar type of questions are coming over these competitive exams like WebG, JEE Main, and other MH set and other different types of competitive exam occurring at state level and country level or national level. So these are the some questions. This is one. First of all, is this is one fluoroacetic acid, chloroacetate, bromoacetate, iodoacetate. So you have to arrange in order of decreasing stability. Okay. So now remember the minus I order which I have just shown you. So remember it and try to answer. I am giving you some time. Okay, I hope everyone has done it. So let's see the answer. The minus I order is this. As you can see that minus I order fluorine is much greater than chlorine, much greater than bromine, and much greater than iodine. So also remember that fluorine is the most electronegative element till date in the periodic table. So always in this type of questions, if minus I effect is the only key factor to decide, then fluorines should be taken as the first priority. So here you can see that the stability order is this. Moreover, as the highest being the most electronegative element, fluorine being the most electronegative element, has a maximum pool of bonded pair of electrons, which results in stabilizing of the negative charge present over the oxygen ion. Because this inductive effect is applicable or effective up to third carbon, and here we have up to second carbon. So the effect is applicable or effective here. Then after fluorine it follows chlorine, and then bromine, and then iodine. So this is one type of question. Another question. Here we can see here we can see another question. The three options you can see. Nitroacetate, ethylene acetate, fluoroacetate. Now in this case of molecules, we have to take in consideration the not only one atom's inductive effect, but together two atoms inductive effect. So just try it out and try this out, and we are now waiting. Just solve it now. Okay, so okay, I hope everyone has done. So now we are seeing the answer. So those who have got correct, I think this is the minus I order. So first of all, I will tell that this reason is that first of all, why NO2 is coming first, though fluorine being the most electronegative element. Here in NO2 there are three electronegative elements playing together, two oxygen atom and one nitrogen atom. Three electronegative elements together are in action. Three elements are together as a showing the minus I effect. So the cumulative effect results in the greatest stability of the that is the in the. And also one thing I need to tell, that stability in the molecule means whenever there is a charged species, the stability of the molecule is assured if the charge can be delocalized over the entire molecule. And since in NO2 it is showing the maximum minus I effect of the 3, there is maximum delocalization of the negative charge over the entire atom. Next is coming fluorine. Fluorine is the most electronegative element, so it follows. Now for ethylene group, the ethylene group, as you have seen in the minus I order, it coming in the last. But also the fluorine has a much more fluorine is far more electronegative than ethylene group, because carbon and hydrogen itself are not so much electronegative, so the combination will never give so much electronegative character. So the solar stability order is this ACB. So today up till this we have learned today about inductive effects, substrate, reagent, and the names of different types of names of the different types of electron displacement effects, and also we have dealt with some questions. We have also seen the minus I order of different groups. You can once more see it, and if anyone has missed the screenshot, missed to take a screenshot, please take it once more. So today we are ending our class. Today here we are ending our class. We will meet soon with our new lecture on general organic chemistry. Till then, be with us, and thank you for watching.